All right, picking up where we left off in the last video, if you notice, I said that that is a dotted line, and then I drew it as a solid line. So here's how you fix this. You just write dotted line and put an arrow, or you grab your eraser, and whoops, I didn't need to redo the whole thing. Let's try this again. You grab your eraser and erase parts of the line. Easy fix. All right, next problem. So example 3, we're going to do this one just like we did the other ones. I want you to pause the video and I want you to try and solve. And really, we have equation 1, equation 2, and equation 3. So 1 and 3 are already solved. And actually 2 is solved as well. So I'm going to give you a second to graph. I want you to start with equation number 2. It's in y equals mx plus b form. And then we'll talk about the other 2 inequalities and how to graph them. So pause the video and work on that on your own. All right, hopefully your graph looks a little bit like that. And I use the test point, my favorite test point, 0, 0. And so we ended up with 0 is greater than or equal to -3, which is true. So we're shading on the same side of that line as our test point. Let's start with equation 1. I'm just going to rewrite it just so we're not looking at multiple things here. So x is greater than or equal to -3. So what this means, right? There's no y value. We can't put it in mx plus b form. We need to think about if x is equal to -3, what does that mean? Well, there's no y values, right? So x is only going to be -3. Come over to -3 for my x value. And if we're going to graph this guy, we know, 1, it's a solid line, and it goes through an x-coordinate of -3, and it'll never be any other x-coordinate other than -3. So it looks like that. And let's see what we got. Put some arrows on here. And so our test point is kind of maybe a little bit strange, but we only have an x-coordinate for the test point. And again, I would test x equals 0, 0. And so my test point, to see where we shade, right, my test point would be x equals 0, and see if we get a true statement or a false statement. So we get 0 is greater than or equal to -3, and that's true. That means I'm shading towards 0, the origin. Now, when I shade this, I don't want to shade, especially when I get down here, I don't want to shade all the way across because we're trying to find the intersection point of this set, right? And so it looks like it's probably going to be somewhere down here. And you could shade it a little more like that, but we don't want to cross these lines because we're trying to find the intersection point. And if you scribble in and just like make this whole intersection point super dark, it might be really hard to graph our third point, right? And so our third inequality is y is strictly greater than 2. So that's going to be a dotted line. And we kind of need to think about this. There's no x's, so just go to y is 2, and that's going to give us a dotted line at y equals 2. And then we need to pick a value to get a test point. And of course, I would pick 0 for my y value. So for my test point, we're going to let y equal 0, and we get 0 is less than true, and then 2. So that's true. So now, like again, I could shade here and I could shade here, but I don't really want to do that because I'm trying to find the overlapping region. So it looks like this kind of triangle area is my overlapping region. I'm going to scribble that in just to make sure we can kind of see what's going on. And you could highlight this or anything if you wanted as well. And so that is our solution set. And again, any point in this solution set is going to satisfy all 3 inequalities. And we could pick solutions on the lines for my light green and my blue function, but we can't pick a point on the dotted lines because that would not work if we plug in that point, because this function is strictly greater than 2. It can't be equal to 2, and that's it. We got one more problem. So let's take a look at this guy, and it's everybody's favorite is word problems. So here we go. A company manufactures two types of printers, inkjet printers and laser printers. I kind of like to highlight some stuff as we go along. Looks like we've got one type of printer and a second type of printer. So the company can make at most, so remember when we're reading these things, we want to look for totals. And that sounds like a total to me. The company can make at most 60 printers per day. Okay, so there's one total, 60 printers per day. And it has up to, so here's another total, up to 120 hours of labor per day. So they can make 60 printers a day at the most, but they only have 120 labor hours per day available. And so they're going to have to use some combination, and they want to try and figure out what all the different combinations of printers that they can use but not exceed 120 hours of labor. And so sounds like a business application. So it takes 1 hour to make an inkjet printer and 3 labor hours to make a laser printer. So we're going to write and solve a system of inequalities to represent the possible combinations of the number of inkjets and the number of laser printers that can be produced using the company's requirements. And when we come down here, they give us like X and Y, and I'm just going to scribble those out. Like, let's make these variables make sense. So what we don't know, we know that they're making inkjet printers and laser printers. And so when I define my variables, I'm going to say that I is an inkjet printer. So I is the number of inkjet printers. And I would say that, yes, let's go with this one. L is the number of laser printers. So we need some inequalities. One total is usually pretty easy to get, one inequality. The other one is usually a little bit harder. So for my first inequality, let's see, my first total is 60 printers per day. So they can make at most 60 printers per day. So they can make at most, so at most means we're going to have a less than or equal sign, and so that's the total number of printers. And we want to equate this total with our variables. So if I is the number of inkjet printers, that was the worst printer word, that's the worst, that was terrible. So I is the number of inkjet printers, and L, so I plus L, has to be less than or equal to 60. That's the number, total number of printers we can make a day. And then we need to think about how we're going to relate these totals, because we've got 120 man hours, 120 labor hours, right? So it has up to 120 labor hours. So it's going to be less than or equal to 120. And so we need to come back to our variables and think about our totals that are going to give us these labor hours. We know that I plus L, it's the number of inkjet printers and the number of laser printers, but we know that each ink print takes 1 hour to make, 1 labor hour to make, and each laser takes 3 hours to make. And so that's kind of what we got going on there. And so those are our equations. And so the man hours, right, 120 labor hours, excuse me, and I equated that back to the hours that it takes to make each printer. If we knew how many inkjet printers and how many laser printers they had, we could multiply that by inkjet printers by 1, which is just going to give us whatever that number is, and the number of laser printers by 3, and we can not exceed 120 labor hours. I want you to graph these two things and unpause the video and check it. So I want you to pause the video, graph it, work on your own. Remember, you need to solve, we'll call this inequality number 1. You need to solve for y. And it doesn't really matter which one we pick. We should probably get some scale going on down here. We could say that, I guess this is I, the I-axis, and this is the L-axis. And if you want to do it as x and y, you could say that's x and that's y. So this would be x plus y is less than or equal to 60. And then this would be x plus 3y is less than or equal to 120. If that's going to make you a little happier, we could do it like that. So I want you to pause and then work on the video, work on the graph and see what we get. We'll come back and check your work. So here is what I ended up with when I graphed it. And you might have had some trouble with this guy. But what I did is I looked at, right, L is less than or equal to negative 1/3 I plus 40. So I know that's my B value, that's my y-intercept. So I found my y-intercept. And then I looked at this negative 1/3 and I just kind of thought, well, that's a gross number, but I could make this negative 1/3, I could rewrite it as negative 10 over 30. So I just took my negative 1/3, whoops, let's try it again, 1/3, and I multiplied it by 10 over 10 to get negative 10 over 30 to fit the scale of my graph. And so this is probably pretty helpful. So we need to check our work. We find our points of intersection, and this is my solution region. We want 3 possible combinations that would work. Well, it looks like if we kind of take the easy way, 0, 0 works. So 0, 0. I want to pick a point on the line too. It looks like, I guess 15, 35 also works. 15, 35, and maybe, do we go right through? I'm not sure exactly, but I could pick that point right there, and that is 50, 5. That's a solution. 50, 5, and that is a solution. So I want you to start working on your homework, and we will answer some questions next time. Good luck.